Welcome.
Hello.
It is now Friday, December
Hello, everyone.
22nd.
Yeah, 3 days to Christmas.
3 days to Christmas. Oof, time flew. So how things going, man?
Going all right.
Okay. So let's figure out what are we doing today. My brain's kind of shot.
We're
doing
reading days 21 and 22,
Okay.
and we're doing answers for day 9.
Okay. Let's get right into it, considering it took us to get through questions yesterday.
But the reading for 21 at least is not that bad. It's a nice break.
Oh, that's right. That's right.
22, I think. I didn't check it out yet, but it's probably less.
All right. Who wants to read? You want to take a shot at this, Alexei?
I can read it.
The Dirac dice.
Let's do 21.
Okay, title ready. Direct dice.
Oh.
All right, day 21, direct dice. There's not much to do as you slowly descend to the bottom of the ocean. The submarine computer challenges you to a nice game of direct dice. This game consists of a single die to pound and a game board with a circular track containing 10 spaces marked 1 through 10 clockwise. Each player's starting space is chosen randomly, your positive input. Player 1 goes first. Players take turns moving. On each player's turn, the player rolls the die 3 times and adds up the result. Then the player moves their pawn that many times forward around the track. That is, moving clockwise on space in order of increasing value, wrapping back around to 1 after 10. So, if a player is in space 7 and they roll 2 and 1, they would move forward 5 times. Space 8, 9, 10, 1, and finally stopping on 2. All right. After each player moves, they increase their score by the value of the space their pawn stopped on. Players' score start at 0. So, if the first player starts on space 7 and rolls a total of 5, they would stop on space 2 and add 2 to their score, for a total score of 2. The game immediately ends as a win for any player whose score reached at least 1000. Since the first game is a practice game, the submarine opens a compartment labeled deterministic dice and 100-sided die falls out. These dice always roll 1 first, then 2, then 3, and so on up to 100. After which it starts over at 1 again. Play using this die. Okay.
So magic dice.
Yeah. So for example, given the starting position, player 1 starting at position 4 and player 2 starting position 8. This is how the game would go. Player 1 roll 1 plus 2 plus 3 and move to space 10 for a total score of 10. Okay, that's 6 plus 4, that's 10. Okay.
Yeah.
Then player 2 rolls 4 plus 5 plus 6 and move to space 3 for a total score of 3. Okay. Player 1 rolls 7, 8, 9 and moves to 4, roll total score of 14. Okay, I'm gonna go into all of them. Yeah. After many turns, player 2 rolled 82, 83. I'm reading on my 82, 83, 84 and move to space 6 for a total of 742. Okay, until we reach actually 1000. One player reached 1000. Since player 1 has at least 1000 points, player 1 wins and the game ends. At this point, the losing player at 745. So here, player 2. Okay. Point and the dice has been rolled a total of 933 times. So we have to do the multiplication after that. 745 from the player who didn't win,
Losing players score.
losing player, time how many times the dice has been rolled. So 993. So which is total of 739,785. Play a practice game using the deterministic 100-sided die. The moment either player wins, what do you get if you multiply the score of the losing player by the number of times the dice was rolled during the game?
All right.
Okay.
This seems quite easy for a day 21.
Yeah.
So I'm scared for part 2, especially because of the name of this puzzle. I searched for the name Dirac, and apparently it's a quantum physicist who was very famous.
Interesting. Yeah, this one doesn't seem too hard, but when it
Yeah.
doesn't seem sometimes,
Maybe it's,
you know,
maybe it's
like-
supposed to be hard because it's circular, because you go from 1 to 10 and then back to 1.
Okay.
But it doesn't seem that hard. One thing that I would point out that you need to pay attention to is your final multiplication number. You're going to use the number of times you rolled the dice, which is not equal to the number of turns that have gone by, because you roll the dice 3 times for each turn.
Yeah. So
Well,
It's a big clue. Okay,
yeah,
cool.
okay.
All
That
right.
one seems doable.
Yeah, it seemed like it was a very short one to read. I like it.
Yeah,
You didn't have to read 18 pages.
right.
All right, let's go on then to 22.
Mhm.
No questions on that one?
No, I think it's pretty
Doable?
straightforward, but one for one.
Yeah. Finally.
You remind me the first few days, you know?
This one looks maybe less straightforward.
Okay.
Let's see.
Day 22, reactor reboot. Operating in the extreme ocean depths. Oh, you guys don't mind if I read this one?
Please go.
Has overloaded the submarine's reactor. It needs to be rebooted. This submarine, man.
That sounds dangerous.
It's like a, what do you call it, plot device.
Yeah.
It's like super smart, yet loves giving you hard puzzles. And now it needs to be rebooted.
Submarine Enterprise.
Reboot middle of the ocean, it's quite dangerous. I don't know.
To find the stupid keys. Doesn't he have like another set of keys? He's Santa Claus, come on. The reactor core, I mean, he could get into a house that's locked, closed windows,
Yeah,
to deliver your presents. Why does he have trouble with the lock?
Well, he's got lanternfish that spawned all across the ocean floor. Can he just have one of them to go find it for him?
Sure. That's up with the story. There. I don't want to denigrate the amount of effort it takes to go into these puzzles, but it was kind of funny to bitch. Anyway, the reactor core is made up of a large 3-dimensional grid made up entirely of cubes. 1 cube per integer 3-dimensional coordinate, X, Y, and Z. Each cube can be either on or off. At the start of the reboot process, they are all off. Could be an old model of a reactor you've seen before. Ooh, before is clickable.
What is this?
And it goes back to day 17, which is, I believe, a day I have skipped. Anyway,
I thought 17. No. Let me check.
is it day 17 the one that you rotate? Oh, that was day. Yeah, that might have been. The
Well,
that-
day 17 was the trick shot one, launching the probe.
Oh, launching the
So
probe.
why would it go to day 17?
Who knows? Anyway, you reboot the reactor. You just need to set all of the cubes to either on or off by following a list of reboot steps, which is a puzzle inputs. Each step.
2020 day 17.
Oh, it is 2020 day 17.
Conway
Oh,
Cubes.
okay.
Conway's Game of Life from last year.
Oh, and it was 3 dimensions.
Yeah. Okay. Sorry.
Oh, yeah, I don't remember doing that one though, but apparently I did it. Each step specifies a cuboid, the set of all cubes that have coordinates which fall within the ranges for X, Y, and Z, and whether to turn all of the cubes in that cuboid on or off. For example, given these reboot steps, on X from 10 to 20, Y from 10 to 12, I'm sorry, Y from 10 to 12, Z from 10 to 12, on X from 11 to 13, Y from 11 to 13, Z from 11 to 13, off 9 to 11, Y 9 to 11, Z 9 to 11 on X 10 to 10, or just 10, Y 10 to 10, and Z 10 to 10. The first step on the X 10 to 12, Y 10 to 12, Z 10 to 12 turns on a 3 by 3 by 3 cuboid consisting of 27 cubes. And it lists all the cube variations below it, very orderly. The second step on, for X11 to 13, Y11 to 13, Z11 to 13 turns on also a 3 by 3 cuboid that overlaps with the first. As a result, only 19 additional cubes turn on. The rest are already on from the previous step. The third step, off, 9 to 11, Y9 to 11, Z9 to 11, turns off a 3 by 3 cuboid that overlaps partially with some of the cubes that are already on, ultimately turning off 8 cubes. Okay, the rest are already up. Okay. The final step on X10, Y10, Z10 turns on a single cube, 10, 10, 10. After this last step, 39 cubes are on. The initialization procedure only uses cubes that have X, Y, and Z positions of at least -50 and at most 50. For now, ignore cubes outside of this region. Here's a larger example. That's a larger example. But oddly, the last two are well outside the 50 range. That's interesting.
What is this?
The last two steps are fully outside the initialization procedure area. All other steps are fully within it. After executing these steps in the initialization procedure region, 590,784 cubes are on. Execute the reboot steps afterwards, considering how only cubes are within the region of 50, 50, 50. How many cubes are on? Okay.
So are we gonna need those last two steps for the full, for part 2 then?
It's kind of odd that they would include it as a sample input,
It's gotta be used for part 2, I'm thinking.
but then why not just include it in the directions for part 2?
Yeah, that's a little bit strange,
No,
like a preparation, a warning.
maybe. So anyway, so we got, yeah, I think it's, other than the fact that it's three dimensions, it's kind of self-explanatory.
Maybe it's just to help you with your input data. So, for example, I'm looking at my real input data right now, and the first 20 lines of my input data are between 0 and 50,
Within the
or -50 and 50 or whatever. Yeah,
within
are
the
lower than 50.
initialization procedure area.
So it looks like for part 1, I'm only going to be using the first 20 lines of my input. And then the next 400 lines have values that are way over 50.
Okay.
So
So part A is the initialization,
Yeah.
and maybe part B is like the serious
it
business.
seems like they just included those 2 lines maybe to get you ready to be able to understand your input.
Yeah. And to prep you for larger
Yeah.
area, or to clue you in that maybe you should make your thing a little bit optimized for larger numbers.
Yeah, because my full input is 420 lines. With a lot of different steps that we'll have to do. Okay.
Is there any numbering system? Because we read our numbers from left to right, so we end up with like the highest ordinal to the lowest ordinal. So it's like 590,784. But to know to say 1,000, I kind of have to first, after I read the 590, or even maybe, how do you know it's not 59 or just 5 as a, as a group of 3? I have to actually start from the left and count the digits, or start from the right and count the digits to know what to say and how to parse the images into the English language. I wonder if there's either a language or a numbering system where it's a little bit more left to right, like we read, like in the flow of reading, or at least, takes into account so that you don't have to parse the number before you say it. When you got into that one puzzle that we had that were numbers in the trillions.
Yeah.
I mean, we had to like sit there and count the numbers before we knew what to say.
There were no
Is it trillion? Is it
I
quadrillion?
think if you had just put commas in there, it would have been easy to read though.
Easier, I think.
Yeah.
But
really,
why not just have a language that starts reading the numbers, instead of tacking on numbers to the left side, tack on numbers to the right side?
Interesting.
We can't, I mean,
I think
someone's
even
gotta
then
have done
though,
this.
even then though, it would still be the same issue because you would have to read all the way until the very far right side to know what you're gonna be saying. You have to completely change the way that you say that.
Yeah, change the way that you say it, so you start from the lowest and go to the top, instead of going from the top and going to the lowest, because you don't know where the top is. Top is the unknown, it's that variable.
Interesting side conversation.
Anyway,
I wonder if there is a language that has something like that.
that'd be neat to
Definitely
know.
not in English.
Yeah,
Could do it. That's a stream. Just give it a name. Yeah, but, I don't know.
like me as a casual person describing, reading a number written on a piece of paper.
Yeah.
Like, let's say it's a number that you look at and you know it's somewhere between 11 and 15 digits.
Yeah. It's angry.
Yeah. The first numbers are 2, 3, 4. Is it 234 quintillion? Is it 23 million? Is it 2
Yeah.
billion? You don't know where the comma goes. You don't know how much there is. Yeah. Anyway, side conversation.
Java, you can separate it by underscore.
No, I'm talking just like spoken languages,
Yeah,
not
spoken is impossible.
programming languages. And programming languages, we can do that, but with the spoken language, because I mean, with the spoken language, I come across this number and I'm just like,
Yeah, it's impossible to read.
I have to start from to the right, parse the number with a number by groups of 3. And now I know what to say. It's even more interesting with Korean, because Korean, we do it in groups of, like the initial group is a group of, we have a nice like group of 4,
Yeah.
right? The man. So when you have to say 200,000, it's in my typical Western brain, I want to say 200
Yeah.
something, but
No,
it's not.
it's
It's 20 something, because
You
I
need to
have
do
to.
some math.
It's almost like I have to move the comma over.
1.80 in French, like 4
Oh.
Oh, yeah.
The video of the taxi driver explaining it was
Fine,
hilarious.
is it? No,
4 times.
that's a lot, right?
Yeah, 4 times 20. 90. 4, yeah, 4 times 20 plus 10.
Yeah, that's what it is.
Makes no sense.
Yeah.
I feel like for day 22, this is gonna be me.
Okay, what is that? It's exhibit. Yo, so I heard you like nested arrays. So we nested arrays inside your nested arrays inside your nested arrays. That's me.
That's gonna be
That's
me on day
already-
22.
That's already me.
Arrays inside of arrays inside of arrays inside of arrays.
Yeah, man. Data structures.
We're gonna
I
have
heard you
4
like-
loops going through IJKL.
Yeah. Matrices, man.
Yeah, that's how we're gonna do it. Did you ever see X to the Z? He had a TV show called Pimp My Ride.
Yeah, I love that show.
Yeah, they modify people's cars, like, but they ridiculous, like, oh yeah, man, I like TVs. So we put TVs inside of your TVs on your TVs.
That was a cool
18
show.
TVs inside a car.
That was a great show.
For MTV.
So many good jokes because of it.
Yeah, of course.
For me, Exhibit is more because of that show that I
Yeah,
know him than
Then his music. I
Yeah.
don't know a single song by him anymore. I just know him as the Yo Dog meme.
Yeah.
We pimped your car.
Yeah.
Good show. All right. Anyway, so let's
Day
move on to
9.
answers.
All right.
Day 9.
Review day 9 real quick.
I have a huge code base for day 9.
Ooh, nice.
Sounds
Excited
good.
to see. Excited to see.
And no comments.
That's not gonna be fun. Oh, I did
Yeah.
comment mine. Or did I? No, I
Let's see.
didn't. Part 1 doesn't need any comments.
He said tentatively.
No.
Alexi, how did it? What happened in part 2, Alexi?
Alexi wanted to do it last night, but last night we finished way too late. It was like, yes, screw it. We arrived home, it was, I don't know what time we are.
Oh man, like one night is not enough for part 2 of this problem. So.
All right, so part 2 was a smoke basin. Oh, the lava tubes. So they got smoke billowing out, and you have to try to find
Smoke.
where the lowest locations for things to settle.
Okay.
And it tries to settle towards the lowest positions between 1 and 9, 9 being the lowest position. And then so you have to find what? The sum of all the low positions. You kind of get an idea of like almost like a heuristic on like this
Where-
little segment of the map. How risky is it?
Where the hills and valleys are.
Excuse me, yep. The sum of the risk levels of all the low points on the height map.
Right.
Doesn't seem too bad, right?
Yeah. So we get into it.
Um, okay, so the map is 0 base, but your score is 1 base. The risk level, the low point is 1 plus its height. And the map,
Yes.
the lowest is always 0. That's interesting. Okay,
Yeah, so if the risk level is 0, then that's 1 point.
Right.
If it's 1, then yeah, it's 2 points.
right.
So it's not too much extra to deal with. Just add 1 to all the values.
Okay, cool. So who wants to present first?
I can go. I
Okay.
think mine's quite short, shouldn't take too long to talk about. Be share. All right, can you see my code?
Yep.
All right, here's my code for day 9, part 1. So first of all, of course, just importing my data. Let's see, my actual data looked like this, probably a 100 by 100 grid. So we'll talk about the sample because it was a lot smaller, a little bit easier to see. So here's how I ended up importing my data, just as an array of strings. So it's nice because in JavaScript, I don't know about other languages, but I can, at least in JavaScript, I can still loop through a string. I can loop through the elements in it. It doesn't need to be turned into an array first.
It treats it like an array.
Yeah. All right, so the first thing I do is I'm just going to capture my lengths, just because I'm going to be looping from the first element in my array to the last element. So I know this length isn't going to be changing, so I'm just going to capture it here to use in my loops. So next I initialize a counter, because my final answer is going to be the count of all of the low points, the risk level of the low points. Next, I just loop through all of my outer elements. So I got my I loop here. And now I want to loop through all of the inner elements in there. I'm going to loop through all of these individual values inside each element in my array. So I start a J loop. And in there, I'm going to do a few things just to make it easier to read. First, I'm going to capture my current number. So my current number is going to be the element with index I, with the element in my input of index I and J. So now I'm going to find out which element is 1 up from there. So right above it. In this puzzle, we're not counting diagonals. So I only need to do up, down, left, and right. So I just capture those accordingly. Up is going to have just an I value of -1. J will be the same. Down is going to have I of +1. J is the same. Whereas left and right will have the same I value, but J will be -1 and +1 respectively. And now all I have to do is I'm going to check if my number is greater than or equal to any of those up, down, left, or right values. I'm going to continue because that number is not a low point. If it successfully gets past all of these conditions, that means that my current number is lower than all of its direct neighbors. So it is a low point. So I'm going to increment my counter, but I need to be sure to increment it by the number +1 to get the risk level. And then I'm just going to print out my count, and there you go for part 1.
Cool. So it looks like you're using a null coalescing on 2021 because there may not be
Yes.
top and bottom rows.
Yes, so I have to be careful on those ones. If they don't exist, then we use the optional chaining here for JavaScript, which is kind of cool. I know all of us have used it many times for objects, but it's a little funny to see it, that you can also use it as arrays too, where you just have to have the question mark and then a dot and then the array index.
Well, array is an object in JavaScript.
Yeah.
That's funny that you use it for up and down, but not for left and right.
Because
Actually,
I only need it for the only time that JavaScript is going to throw an array is if I try to get the sub object of this main object. So if the main object exists, then it's not going to throw an array if the sub property doesn't exist. If the sub array or the
So what does it give
sub-element
you?
doesn't exist.
Does it just give you a null or a zero, I guess?
And
is the
define
first
it.
sense?
Yeah.
Or does it give you not a number?
Define them.
Maybe undefined, but
And then undefined less than or equal to? Maybe that always ends up being not.
yeah.
Interesting.
I mean, this one, yeah. This one didn't throw errors at least, and it worked out fine. I didn't need to handle it. Whereas these ones, if I try to get this index value of this array that does not exist, then it will throw an error. Cannot find property of undefined. So that's all we got to do for that.
Cool.
Yeah, actually, this is one new thing that I learned this year, actually. Well, I learned about optional chaining for objects last year, probably late into the year, maybe November or December. And then actually just recently I learned that you can also do it with arrays, which made my code so much cleaner in JavaScript. Because I remember doing similar questions to this last year, and I had to have a lot of if conditionals for if this array doesn't exist. And it's so much nicer to just be able to do it with 2 extra characters. Just a question mark and a dot handles that for me.
Yeah, that's interesting that it doesn't crash after the if.
Yeah.
So if it doesn't exist, then the parse int at least gives you back something that's not gonna crash. Right? Because let's say
Well,
If we do a console log of
yeah, let's just console log my right ones and see what they end up as. Yeah, so it looks like it comes out as not a number. Non-red. Yeah, so then if I do a greater than or equals not a number, I guess it doesn't throw any errors.
Can you just run node right in your command terminal? And then let's try non greater or equal to 10.
False.
Yes, it's always going to return false.
Yeah.
Like this.
So
I'll try 0.
10 greater than or equal to 9.
Let's try
False.
0. Non is greater than or equal to 0. Is it going to be true? Does it treat 0 as, I don't know, it doesn't. How about non greater or equal to undefined? Java's fun to play this way.
So it looks like it's always going to be false then.
Non is greater than or equal to non. Oh,
It's not.
how disappointing. There's not a WTF in here.
Non equals non. False.
How about triple equals? Oh,
How could it be triple equals if it's not double equals?
that's true. You got me there.
I mean, JavaScript is weird, so it could be. It shouldn't be, is what I mean.
Yeah.
Yeah, so it looks like any kind of operator like that with non always returns false, which is exactly what I want it to do here.
Yeah, for here, it's great. Yeah.
Because I did the same, but with generaries, and because I was afraid that it would crash.
Yeah, the optional chaining made it a little more
Shorter.
succinct here, a little shorter.
So that is the format of the puzzle.
Mhm.
So same as code actually. Just return
Array
line
of
by line.
strings.
Some of the risk level, and then I just look through the puzzle here, what it's got. Then after that, I just split each line into an array of number, and then I just look through every of them. And then instead of doing the optional chaining as Scott did, I just check, oh, this exists.
Yeah,
If so, then I return it. Otherwise, I put 10 because we know that the biggest in a puzzle is 9.
Right.
So I just put 10, and then after that, just to make it shorter to look, just save it in one variable current, and then just check if it's bigger than up, down, smaller than up, and smaller than down, left and right. Then after that, I first equal current and 1. That's what they ask. The 1. Yes.
I have a question though.
Yes.
In your line 20, you're only splitting the current line, right?
Yes.
But then you're checking the line above it and below it. So the line above should always have already previously been split, right? No.
It doesn't have to be because it's a
No.
string, so the split is really unnecessary.
Yeah.
You can
I
still
think you
use
don't
it
need
as an
this-
array.
You don't need this split thing.
Just
Because
I
you're
think
checking
to
the
have
line
it as
below
a
it.
double, I think.
Yeah, but with JavaScript's
Yeah.
very loose typing, your less than and greater than is going to convert into a number before this comparison.
This one you mean?
Yeah, so your up, down, left, and right is always going to be a number,
Yeah.
or it's always going to be a string. But then when you do the integer
That's
comparison,
interesting.
and then it converts it into a number.
Yeah.
All that happens magically for you.
Yeah, so line 20 could probably be gotten rid of and it would still
Yeah.
work fine.
I don't think so. Because you don't rely on that to be a number.
Do it. Try it. Just comment it out for now. Yeah.
There was a puzzle. Okay. I.
For the I.
And my solution was 428. Exactly the same.
Yeah.
Exactly the same.
So you don't have any that are equal.
No,
Interesting.
because it has to be smaller in the first part. In part two, it can be equal.
Mhm.
I remember reading it. But
Okay.
the part one, it has to be
Yeah, it's too small. Right?
smaller, the smallest. That's why I didn't put equal.
Okay. But Scott, you put less than or equal, but it still worked. What did you use? Greater than or equal instead of less than or equal?
I was using greater than or equal to.
Okay, so you still eliminated equals.
Yeah.
Cool. Why don't I go next?
Hey,
Since you've already, Farouk admitted you have pages to go through.
what was that?
You admitted that you have a long solution to go through, so I'll go next.
Oh, no. Part one is not long. Part two is long.
Yeah, I think part two is gonna be long for pretty much all of us. No?
Not mine. You
Super.
didn't start. You didn't start, so it won't be long.
0 minutes.
0 lines of code.
So are you going for part
No
one or me?
No commissioner.
And so here is what I did not do.
That's piece of art.
Who's
Yeah.
next?
Runtime of 0 milliseconds. All
So
right.
Alex, yes,
Yeah, let's shake it up for a day. I'll go next.
we always put the same one.
So we'll shake it up for today and see what happens. All right, so I think this is my screen. It is 9A. Top part is the same as all my puzzles. I always start out with my samples and the code itself. Well, not always, but most of the time. Then I format it into the data structure or whatever structure I want to. Typically in these puzzles, it ends up being vectors. So this is a vector or arrays in other languages. Yo, dog, I like arrays.
Yo.
Arrays in my arrays. So, but this time I'm doing an array of integers, 32-bit integers. And like yours, like you guys have done, got a for loop within a for loop. Only difference with mine, I guess I check all the neighbors independently. Oh, yeah, because I have row checks to see whether or not it's the first line or the last line. So if it's not the first line if it's not the first line, I do one thing. If it's not let's see, if it's not the first of the row, I make sure I don't go to the left, stuff like that. If it's not it's less than, okay, so if it's within the group, then I have another check. If it's within the rows, I do another check. So it
You have
just,
to do all those checks to make sure you're within the boundary.
Within the
of
boundaries. Mhm.
Okay.
I could probably, now looking at the code, there is ways I could optimize instead of doing so much copy paste, but I did that, and I think in part two, I end up summarizing a lot of the stuff I had written here. And then on the bottom, if it's different, then it's considered a number that I'm interested in, the lowest number. And then afterwards, I put the lows in, and then I also, it's not required, but I kept a separate list of all the lowest coordinates just because I was kind of interested to make sure that my thing was working. And then I do the math required. Yeah, add 1 to everything and then print it out.
It's still really hard for me to read your Rust, even though after 10 days. Like, if you ask me to re-explain,
Still,
like,
yeah, no
for
way.
some basic,
No.
I would, but otherwise, it's still like the first few lines is a mystery, the vector in vector. That's
A lot of it's
hieroglyph
just typing,
to me.
man.
A lot of it is typing, like that's typing, that's typing. This is how you create an empty vector. I just have to add the vec, but this is actually called a macro. It's not really a function or a keyword. It's just something that was added onto the language to make it easier for people to make empty arrays or empty vectors. Anyways, you see a lot of iters. It just means that it's a collection type. It's a type that I can iterate through like a vector. So a lot of these vectors will see iter. Then afterwards, it's something I can do as an iterable. Yeah, I do a lot of reduce. So reduces end up being a little bit difficult to read, but essentially the first parameter to any kind of reduction is my accumulator. How do I initialize my accumulator, the thing that I'm going to be adding everything into? And then I have the parameter list, and the parameter list for reductions usually is the accumulator itself, because I have to keep passing it every time I run it. I have to pass in the accumulator, and I can change it with every iteration or not, up to me. And then the data itself that is going to be relevant. 1 data element per execution of the reduce. And then cars is just to convert string into characters, but it's an iterator as well. It's just a character iterator. So I don't have to create an iterator, then turn to characters, and then fuck the characters. It saves me 1 step to turn a string into characters. I can turn it immediately, turn a string into an iterator for characters in the string. And then collect takes that iterator and says, I'm not going to iterate. I just want you to get the entire thing that you're going to iterate over and bundle it up into 1 thing. And that ends up being a vector. Okay, a vector of characters. Other than that, I have a map. A map always takes 1 parameter as an X. I have a parse, and the parse needs to know what I'm going to parse into, or how I want to parse mine, because I don't have just 1 number type. I have like 8 number types, or more, maybe even. Yeah, especially if you include like the sizes. But anyways, and then unwrap just means I know that the parse might fail, but I'm going to ignore the failures, just panic and crash if it fails. I'm pretty confident my input's going to have numbers, and this is just a test or a play kind of program instead of a serious production program. So I can kind of be loosey-goosey with my error handling. So I'm just going to unwrap, which just means ignore the nuns, or rather crash on the nuns, knowing that there's probably not going to be, if any, crashes, because they're all going to be numbers. But if there's not any numbers, the unwrap will crash. We'll crash the program. But it's not a number. And then again, collect. To take all those results and stick it into some kind of collection. In my case, the collection is going to be a vector of numbers. So all these you have to be very explicit about what you're going to create, when, and how it's all going to come back together. And so a lot of it is just.
All your initial formatting is a little harder to understand. Your actual like logic code though looks quite readable. It looks very similar to like it's almost looks like a mix between Python and JavaScript.
Right.
And I'm thinking it might be because I'm not absolutely certain, and probably not. My code is probably not like idiomatic Rust. Like a person who's been programming in Rust for years will probably not look as C-like in terms of the way I'm writing this. Maybe it will, I'm not sure. But I have seen other Rust programs, and I'm not good enough or have enough experience with Rust yet to know, well, this guy's just showing off, or this guy is actually, this is a good solid production solution, right? Because you see solutions in JavaScript all the time, and if you have enough exposure to JavaScript, you're like, oh, that's really cute, but we would never use that. Right? It's great for programming, it's great to do puzzles, but you'll never see that in production. And I'm not there yet with Rust in terms of being able to distinguish the two. So when I see my code, I'm sure people look at this and like, oh yeah, you came from a C programming background like this. We don't do it this way.
That's how you think.
Yeah. I'm certain Haskell was like that, because a lot of the Haskell code I see, I'm pretty sure they came from a mathematics background, because all their variables are single letters. It's like X, Y, A, Z, Q, and it's like, how do you keep track of any of this stuff? But, you know, being a mathematician, that's the way that you've been trained over the years to, you know, isolate variables. It's just through numbers, and you kind of have it in your mind what these, you know, what these X's and Y's mean. But as a programmer with a C background, it's a lot more difficult for me to do something like that. And so, like, in terms of columns, like, I'll use a lot of columns because my variable names will have a certain length, and then I'll write things out a certain way. And but the quote unquote pro Haskell, a lot of Haskell programs I see, my program will easily go into maybe 40 columns, like half a page. Their programs are like 10 columns large.
That's all.
Yeah, they're all single letter variables. They're about 10 columns wide. And they may or may not even be the same number of lines of code, because they'll do a lot of recursion, a lot of manipulation with iterators. And I'm still trying to grasp this idea of lazy handling, which I'm starting to scratch the surface of, and I'm starting to appreciate, but the power of it, I haven't really fully grasped the power of the lazy handling and taking advantage of it. But that's also great strength.
I understand why it's used in security. You said it's used in security.
Well, it's just used in backend for memory security, just to make sure that your program doesn't go beyond the bounds to which you want to restrict it.
Because it's unreadable, so no one's gonna hack it. Let's go for JavaScript, you know, it's so easy to hack.
So we see Farouk's code? Let's see some
Yeah.
Python.
See some Python. Go from the least readable to
Right.
the most readable.
I prefer Rust to Haskell. Your Haskell is unreadable.
That's what I mean, man. Haskell is, it's another world.
It's completely unreadable. Your Rust seems
You guys see
quite familiar.
Yeah.
my screen?
Yep.
Okay. So as usual, I have my input 2, and my input consists of an array of columns. So this is my first input. So this is the first row and second row, and so on. So I'm looping through my array as it is. I'm not converting it to anything else. As Scott mentioned, I'm also looking through these elements inside the string. So first one is for the length of the array, and second one is for the length of the row. And in this case, we have to check 4 elements: up, left, right, and bottom. And we have some edge case, like in this corner, we don't have the left and we don't have the up. So I'm just taking into account those edge cases, and for the rest, I'm just comparing it with the 4 elements if it's lower. And my first condition is here, which means if my y is not here, I'm just excluding this line. If my y is not here, I'm checking the lower part. I'm checking if it's bigger, and also it's not here. So I'm excluding those 2 edge cases, and I'm checking if it's lower than the next one, if it's lower than the bottom. I know if it's lower than the up, and if it's lower than the bottom. So I am proceeding to the next condition if it is true. Next one, if it equals to the last one, if it equals here, it needs to be lower only from the up. So if it equals to the last row, I'm checking if it's less than the previous row, element in the previous row, which means the element in the up. And the last condition is if it's a 0 index row, I'm checking if it's lower than the bottom element. So if those cases are true, I'm proceeding to the next condition, which is if my x index, which is my row index in the row, if it equals to 0, it needs to be lower only than the next element, which means the element in the right. So I'm checking this in here. if it equals to the last element in my row, if it's here, it needs to be lower than the previous one. So if those cases are true, I'm adding this element to my array, and otherwise I'm just ignoring. And I have another case here. Otherwise, if my x doesn't equal to the 0 index or the last index, it needs to be lower than the left and right elements. So I'm checking if it's lower than the right one and if it's lower than the left one. In that case also, I'm adding it to my array. That's it. And I'm summing them up here. I have my sum. So, and returning my sum. So this is my lowest points, 1, 0, 5 in my sample input, and the sum is 15.
All right.
Cool.
It looks like we all did pretty much the exact same thing for part one. We only had to, I guess, depending on the language, some of us had to take into account the special cases where there is no upper row or left row.
Yeah, to take
But
into account.
other than that, the rest of the code is the exact same pretty much. You just loop inside the
But-
loop.
I'm also wondering regarding, like, I do not have any parse int. It just hit me because I saw parse int, and maybe Python is also doing automatic type here, type conversion.
Yeah.
Okay. So both JavaScript and Python do automatic type conversion.
It's a loose, they're both loosely typed, right? And I think if you do a character comparison, you might actually end up doing a comparison against the ASCII value, the character value, rather than the actual value of the number itself. You know what I mean? Like A starts at 97, I think zeros
Yeah.
starts at like 60 something. Which, you know, for our code wouldn't make much of a difference. They're all single digits. It's when you get into the double digit numbers and then you'll get into problems with that.
So then
We have to convert it to int, right?
Right.
If we,
Because a 10 is a 10 in integers, obviously, but with characters, you'll end up with it's 2 characters instead of a single number together. So you may end up doing a comparison against the first. At best, you'll do a comparison against the first digit of your 2-digit number rather than the entire number as a whole. Your comparisons.
So do you need
Okay.
to convert to-
should I proceed to my part 2 or?
Oh, let's read the
Someone
discussion
else
for
wanna-
part two.
No,
Okay.
yeah, you could do one.
Yeah. Like, make it safer for double G.
Let me share then.
But above on X, it wasn't doing.
So for
Hold on, it's.
part 2,
On my 23 was I. He converted it with int, he passed it with int.
Mhm.
But which above he didn't do it with X. But still he was comparing X
Oh, okay.
with
Oh, yeah,
0.
yeah, then maybe it does.
So that's why it's
comparison.
confusing. Maybe the int, it doesn't need the int.
Let's read
right?
part two.
So part 2. For part 2, we need to find the basins. Basin is locations that eventually flow downwards the lowest point in the map. So, for
Every
example, in our
It's going to be part.
example, we have 1, and for that one, we have the 3 to 1, which is flowing downward to 1. And for example, for this 0, we have other numbers from the left, 4 flowing downward, or from the bottom here, 4 flowing upward first and rightward, and 2 flowing. So basin is the area where higher elements flow downwards the lowest element in that area, I think. And we have to find all of these integers and sum them up. We have to find the 3 largest basins and multiply their sizes together.
So is it just those who, is it just all the areas that are not 9?
Yes, essentially, that's what it ends up being. It's every basin ended up actually being just bounded by 9s.
I was confused because in this sample, it's actually confusing because let's say this 5, every element in this bound is linked like one integer upward. For example, here it goes 5, 6, 7, 8, and 5, 6, 7, 8, 5, 6, 7, 8. I thought the number needs to be one integer higher than the lowest number in order to be part of the Bayesian. For
But you have an
example,
8 to the left of the 5.
Yeah. like
yeah,
if-
and for that 8, I thought
If you go down from there, it's a
that-
7, so it goes 8, 7 eventually.
for this 8, I thought it goes
No,
like
but
5,
5,
6,
6,
7, 8. Like 5 here,
Back
and
up.
6,
You know which way to go.
7, 7, and 8.
You can't really know which direction you're going.
Yeah, but I see where you're going with that, and I think that's, you know, I don't remember exactly. I have to look through my code again. That might be what I've done before as well.
Yeah.
But that's not a true approach because in my sample, even the difference was higher than 1. For example, yeah, 3 or 2. I think it was included in the Bayesian.
Okay.
So pretty much each basin was just bounded by 9s completely,
Yeah, I think.
because 9 can never be a part of the basin.
Right.
Yeah, that's the part 2.
And then for the final answer, then we had to find all of the basins, and we had to find the 3 largest basins and multiply together the sizes of the 3 largest basins. That was what we have to do for our final answer.
Okay.
I can go first.
Yeah.
All right.
So what was your approach on this one?
My approach was to use recursion.
Mhm.
So let's say I found the lowest index. Once I found the lowest index, I pass the next element to it as lowest index 1. And I include first lowest index. For example, I found 0. I add it to my list for that Bayesian, and I pass its next element to it, for example, 1, into my function that checks if it's a low element. And if it passes a certain condition, I add it to my list. If it has a lowest element next to it, let's say 2, I'm checking if the difference is 1 or 2 now. If the difference with next item with left or bottom is 1 or 2, I add it to my array and pass 2 to my function to check if it has a lower element next to it, for example, 3. In this case, its difference is 1, so I will check 3, and so on. And 3 has 4 here, so I check 4, and 4 doesn't have any. It will go back to 3, and 3 checks the bottom of it. You have 4 to my function, and 4 doesn't have any, so it will go back to 3. My recursive function will go 1 level up, so 3 and back to 2. Nothing here, back to 1. We have 2 on the bottom. We'll take 2, and we'll go back to 1 and 0. We'll check bottoms, and that's the approach.
Yeah,
Every
so
time
you-
recursively checking every index, if that element is has 1 or 2 digit difference with the current item.
Yeah. So using a depth first search.
Yeah. So
I think I did the same thing.
regarding the code, for example, same. The first part is same. I have a loop here, right? And I'm looping through the same way I did before, right? So let's say I found my lowest point in my map, and after I found that lowest point, I add it to my array. And after that, I will pass the same input and my indexes in that map, X and Y, and 2 empty arrays to my find coordinates recursive function. So find coordinates will start recursively checking if it's, it starts from the left. I compare the left if the difference is 0, 1, or 2, and the left element is not equal to 9. If it's so, it will add that to my empty array, because I have to get all the elements in that Bayesian, So I add my element to my basin. I also store the index so that I not get duplicate values. So if it is lower, then I will call my function again with the same input and this new indexes and my basin and indexes. We'll call it again. So I have a list of my conditions, list of the indexes and the difference. As soon as it matches it, it will call the function again recursively. And at the end, I will return the length of my basin plus 1. And I will store it in my sizes array here. So I will sort them at the end. And I will get the maximum 3. And I will slice it here. So 3 sizes from the end, which means the 3 largest. And I get the multiplication and return.
Okay. On your comparisons, like on 61, 55, 43, and so on, instead of using in as an operator for another set,
Here.
would have been the same thing if you just said less than 2, like less than 3?
Yeah, because this was actually the confusing part. First, I had it only 0 and 1. Then I debugged and realized it can even be 2. And then now it's obvious, like, it can be 3, right?
Yeah,
So
or less than 9.
that should work.
That's what I did.
As long as it's less than 9.
Yeah.
So you can get rid of actually the last 2 things and just make the whole thing less than 9.
Right, you mean this part, right? Oh,
Yeah, that's what it ended up being. It wasn't clear by the instructions though.
Well, the instructions did say all the numbers except 9 will be part of some basin. It doesn't know which basin. Right, because right after that statement where it says
Yeah.
everything except 9, or 9 is not part of any basin, and then it just says like all other, sorry, all
And
other
all other
locations.
locations will always be part of exactly one basin. Yeah. So I guess.
oh, I got index out of range. Let's see. Is it the right answer? No. Oh, answer is not
So it's not the
correct
same.
if it's no, if it's less than 9. Let's try less than 3. Oh, even less than 3 is a different answer.
Oh, okay. The difference is not the numbers.
Yeah.
Gotcha. Yeah, okay. Yeah.
What was that difference? Is not
You can disregard the difference then, right? So
Yeah,
then the
you don't
entire
need the
first half
difference.
can go, and then the whole thing could just be as long as the input does not equal 9.
Yeah.
all right.
The entire first part can go away.
So my current index is x1. You mean I can check this number?
No, everything from after the if to
Right.
your last and condition.
Yeah.
So as long as it's not 9,
We're gonna include it.
then we can include it because you're traversing all the neighbors, right? And if we assume that the neighbors, everything's gonna be part of exactly one basin, and 9s are not part of any basin, then we're, like you said, bounded by 9s, right?
Yeah.
You still got a string index out of the thing. Interesting. Just by removing the if conditions?
E less.
Well, it should change. Should
Interesting, right?
what the conditions are. The if condition, the condition shouldn't change anything. That's odd.
Maybe my
Get something in there we want.
my recursive function is being called too many number of times. Stack Overflow. String, first one. Oh. Even
so-
removing the only first one is
Well, because some of them, are you not taking, are you in these if chain, are you taking into account like going above the first row?
It looks like for some of them he is.
So the find coordinates, that function has to take into account unreachable values, right?
yeah, it is yeah. For example, here I'm checking if the y1, which is vertical
Right.
coordinate, is less than the number of the x, which means it should not be here.
Okay.
I'm excluding.
So
I'm
yeah, so
checking
that
this
logic
one.
has to stay. You have to at least have that logic to bound your find coordinates.
Ah, all right. But this one doesn't have that one. It doesn't have that logic. So probably it has to stay, and we can remove.
Well, what's y minus one then? If it's a last row, y minus one will fail, won't it?
Which one? This one?
Yeah.
I think here, if it is here, it will return, it will not pass this condition. Even if it's the last row, it will not give an error, but doesn't pass this condition. So only these rows will pass the first condition.
The way it's written now, right? So we can't get rid of it unless we replace it with something that does something similar. Right? Is that where we're at?
Yeah, yeah. 1 minus 1. So it's basically the up. For this one, it's checking this here. For this, it's here.
So the first row, it's going to fail then.
It's in the parallel on the very first element.
Yeah, the first element.
Yeah.
So the first one can be just if y is greater than 0 and the integer of the input of the x of the y minus 1 is greater than 9, I think.
What does that? If y
Is greater than 0.
and
That's all.
Oh, you can get rid of the and, keep the
Yeah.
old and.
Yeah, and now just like that. Yeah, so everything there looks good.
And you can even make the last one greater than 9 instead of less than 9, but it doesn't matter. It's
So
the same.
like that?
Yeah, let's see if we get the same answer for that one. Is that your answer, 1350?
Let me check. No, it's 1134 is the answer.
134. So that one actually got more in.
And this is the right answer.
Okay. Well,
But less than. Yeah,
That's,
less than 2 worked, no?
it should.
Wow, even this is not working.
Huh.
Should be less than in 1, 0, 2. Less than or equal.
Oh, okay.
Oh no.
Yeah, because less than or equal is it increases the number.
Yeah.
Or we were already over with like 1500 or something like that. So there's something else happening there.
Okay, this is my approach. It took me a while actually. It was much many lines than this, and I managed to remove quite a lot of them actually.
Yeah.
And this is the remaining part. My solution for part 2.
All right. Well, let's not try to debug in place. You got a solution that works, so that's good. And then we'll try to figure out how to optimize another time. But cool.
Interesting.
Yeah.
All right.
So who wants to go next?
Let's see. Just kidding. I'll go. All
I mean, you can
right.
also just talk about like how you thought about approaching it. I mean, it doesn't have to be like solutions. I mean, it's interesting just to talk about the approaches themselves.
I just read it. I didn't even try to solve it. I remember solving the first part and it was already really late. So I was like, okay, let me just read part two. It's like, yeah, it's gonna wait next time.
Yeah.
And then yesterday I was like, yeah, too late.
Yeah, I'm like that with day 21, I think.
Yeah. So, well, to save time, I'll try to just go through how I thought about it and what I did to implement it. So same thing, I imported my data as the exact same structure, just an array of strings. Although for the actual input, it's strings with like length 100, so it's quite a bit larger than the sample. Again, I captured my lengths of my entire array and the length of each row. And they're all the same, so there's no variation there. It's nice to work with. And then I initialized two separate arrays. So the first one here is basins array. I'm going to use that, I think, later to keep the length of each basin that I find. Or store so the number of values in each basin. So how big is the basin? And my second one is going to be used each time that I find a low point. I'm going to store all of the index values of each point that's included in that basin. And this one will get reset every time I move on to a new low point. So we'll temporarily keep a list of indices inside current basin.
Before we move on really quick, because I'm gonna forget this by the end of it.
Sure.
For your last one, that minus, I just realized if you take a smaller number minus a larger number, you're gonna end up with a negative number. With a -2, that negative number is gonna be included in the count,
Oh,
right? And so yours is only including those that are going down. You're not including those that are going up. That's
so I have to make smaller than 2, but higher than 0.
So you can take an absolute value.
Yeah.
Okay, let me check.
Yeah.
Okay.
But yeah, I'm sure there are gonna be some other
Yes.
problems that we haven't gone around, but
Refactor.
I realize that because of that weird thing with subtraction is that you can't mix numbers. But anyways, let's get back to this guy. Sorry,
Okay.
sorry for the interruption.
Okay, well, after creating the data structures that I'm going to use later, I have a function called check neighbors that I'm going to come back to later. Let's first go to my main loop. So again, just like part one, I'm going to have a loop inside of a loop. I'll call it my I loop and my J loop to get to the inner elements. And all of this part is pretty much the same, except here, every time I'm checking a new number to check for a low point, I'm going to erase my basin array. So I'm going to set it back to an empty array. I'm going to clear it out.
Create a new basin.
Yeah,
Start a new basin.
start a new basin. So now all of this is exactly the same as my part one. If you remember it, I'm just checking the up, down, left, and right elements if they exist. Hence the optional chaining. And if any of those, if my current number that I'm inspecting is larger than any of its neighbors, I'm gonna continue with my loop, meaning I'm gonna skip everything else and go on to the next number in my J list. Because that means that is not a low point. I don't even want to consider it anymore. I'm gonna ignore you. Now, if I get past all of this, then yes, it is a low point. So I can add that to my new basin array. So that's going to be point 1, the very first point of my basin. And now I'm going to check all of its neighbors. So I'm going to do 4 function calls here, 1 for each of the neighboring elements. So, and after I do that, I'm going to push the total length of my basin. So my basin array should now be populated with at least 1 element, hopefully more, probably more. I'm going to push the length of that array into my basins array. Okay, this basins array is not going to get reset anytime. It's going to keep growing to collect the size of all of the basins. So let's go on to my check neighbors function. That's the meat of this problem. So this is a nice recursive function because it's going to have to keep calling itself to keep growing the basins as long as they're bounded by nines. So I have a few conditional checks in here just to see if I even need to continue with this function. So the first thing I'm checking, just to be safe here, is if the current element I'm inspecting even exists. If it doesn't exist, break out of the function. Next, I'm checking if this element that I'm currently inspecting is already in my basin array. If I've already added it, if I've added this I and j value as this string here, I, j, then I'm going to break out because I don't need to check the same value twice. Next, I'm checking if this current value is 9. If it's a 9, I don't want to keep inspecting it. I'm going to break out. And some of these are just for safety. It shouldn't get here. And this one, I think, shouldn't be an issue. But this one is quite important. Next, if it successfully passes all of these conditions, I'm going to add this element to my basin array. This element is part of my basin. And next, I'm going to do just what I did before. I'm going to capture the current elements that I'm inspecting, my current number, my up, down, left, and right elements. And I'm going to check if I have to check these all individually. That's why I have a bunch of individual if statements. So I'm going to check for my up element. If the item right above the current element I'm inspecting is less than 9, I'm going to do my check neighbors function on that element too. If my down one is less than 9, I'm going to check its neighbors. If my left one is less than 9, I'm going to check its neighbors. If my right one is less than 9, I'm going to check that one and its neighbors. So my functions are going to grow really fast. It's good that the input wasn't too much bigger, or this could really, really overload my CPU, I think, with lots of different functions being called at the same time.
Stack Overflow.
Yes.
But
luckily, I didn't run into that with this one. My code ended up running almost instantly, I think. Let's see. Yeah, those milliseconds were my final response to get through. So I didn't run into any issues here. In the future, in Advent of code, I know there probably will be recursive functions that I will write like this, where it will be stack overflows because the inputs will be 1,000 lines by 1,000 lines instead of 100 by 100. But for this question, it worked. It was quick to run, and it got me the right answer. Just had to check each neighbor, and luckily, each neighbor was only bound. Every basin was completely bounded by 9s, so the conditions were quite easy to check here. Nothing too tricky. Yeah, so so at the end of checking an entire basin, that basin array will be populated. And then I'm going to add in the length of that basin array to my basins array. So to get the final answer then, I just sorted my basins array, and I was only interested in the final or the largest 3 elements. So I took basins 0, 1, and 2 and multiplied those all together.
Can you scroll up again really quick?
Yes. Which line are you interested in?
Could you have, again, maybe it won't work, but scrolling down now, could you have just passed, so line 65, 66, and that block of all the checks,
Yes.
could you have just passed in check neighbors ij? And then have that function take care of checking ij's neighbors?
Yeah, I think that would work fine too. Let me. Actually, no, because of the way that I have my function, it would fail on this check right here.
Oh, because it already included it.
Yeah, but then I could just take it out of here
Include it afterwards.
and now see.
So does it? Oh, because it also writes to JSON array.
Oh, that's the work side.
Yeah.
So yeah, that's a little bit more, saves a little bit of efficiency on round 1 at least. Yeah, how about that?
All right, cool.
All right.
So very similar recursive.
Yeah,
recursive
just
checking.
It's a little bit nice that I don't have to do all of the checks for if it exists. I just have pretty much one check up here. If this element that I'm checking doesn't exist, then I'm just gonna return. Otherwise, I can continue.
Right.
Yeah. So really, overall, it's not that much code.
Yeah.
Quite short.
Cool.
But it was only day 9.
Yeah.
They've gotten way harder since then.
All right. So go to-
Alexi. How are you?
Alex, you want?
Do the joke.
Alexi's getting kebab tomorrow. How about that?
Wow.
Maybe he's gonna
Oh,
empower.
Yeah.
Up to line 18, 19, 20, they're all the same from the last one. I started by trying to do a function that tries to do a lot of the stuff that I wanted through like pointers and stuff, and no, it didn't work.
Like your comment, a weird function that tries to change the primitive value, return a value. Obviously a train wreck.
So that didn't work. But I left it there for you to gawk at and see
See your
the
thought
height of my
process.
stupidity. I have a utility function called get neighbors, which is very similar to what you just saw with Scott's code, so we'll get to in a second. Another one called get low points, and get low points is basically part A, but put into a function. And then I have follow basin. Follow basin is just another function that does all the recursive calling instead of doing the checking of the neighbors. It just does the recursion of who to put in next. And then I have my actual body in my function. So very similar, create a basin sizes array so that I have an idea of something to sort at the end because I want the 3 largest. And then after I create that low points function, I call the low points function to get my low points into a vector. Don't worry about U-size, it's just another number. One of the many great numbers that are available to you and are not intercompatible sometimes. Maddening within this language. But anyways, so basically I got all my answers from part A, all my low points. And then for all my low points, I reset the basin count, very similar to what you had done inside of your for loop. And then I follow that basin to see where it goes from that low point. And follow basin from that low point. Well, depending on my checks here, whether it's not equal to 9 and whether or not these things even exist, right? So I do a contains to see whether or not that thing is even a part of a basin from the total basin, or basically my input. And if it is, then I push into the array, and then I follow and go to that basin, which calls itself again. And so at the end of this, I should just be at least getting an idea of where I can traverse. And as long as it's not 9, I'll be able to go into it. And that's about it.
All right. Very similar to mine then. Just a little bit.
Let's get neighbors. Oh, get
More
neighbors was
separated
only
ones, I
used from get low points. I used get neighbors. That was part of part A. So get neighbors and get low points are both from part 1. I can actually say that here because it's both from part 1. All my long weird sections. All this crap that we were kind of gawking at before was, streamlined into this.
Okay.
And then, but so part B was just follow the basin, and the really critical thing was just as long as it's not equal to 9.
That really made the problem so much easier. The first time I read it, I didn't realize that that's all it was saying. It seemed like, yeah, you had to find the repetitive ones where it goes like 8, 7, 6, 5, 4.
In order.
Yeah.
Because the sample was leading that way, right? Sample was,
Yeah, for the most, kind of.
Some of them were unclear though.
Like they have one, like on this one, I think this is what kind of did it for me, is like, go from 5 to, do I actually have to go like down here and over?
yeah, I mapped it like that.
Yeah.
And then what do I go here in this corner and then go here and then there? I'm like, no, I'm just gonna check the neighbors. That's when I realized there's an easier way to do this. But you could have done it that way, that first search, obviously.
Yeah.
That was an option.
I think the wording of the puzzle was a little bit tricky.
Sure.
Because yes, it does say that every number that's not a 9 will be part of exactly one basin, but before that, the description of what is a basin was really vague. It was kind of
Yeah.
confusing.
Yeah, what's included and what's not included.
So yeah. But once realizing that everything was bounded by 9s, the question became a lot easier.
Right. And so I think, when we were thinking about your code, Farouk, I think that's what we were trying to do. We're trying to simplify your logic to just not include 9s rather than, doing subtraction and then seeing whether or not it's a certain distance, because the distances didn't really matter. Distances between two values didn't matter as long as one of the values was 9. Then you hit a wall on your basin.
Yeah.
Yeah. So there you go.
It's a good exercise to sort of practice with recursion.
Sure. Yeah.
Because it's really the only way that I can see how to do it. Because you can't just loop. You don't know how many times you have to loop. You have to keep spreading.
Right. Yeah, 92 minutes. Don't know how large it is.
Yeah.
When you first start.
Yeah, it was a nice exercise. We have more graphs coming up, I think.
I didn't actually check my basins array at the end. I wonder how large or small did the basins actually end up being. I didn't ever console log my basins array to see just the size of them.
All right.
Do we have any basins that are only size
I
one?
checked them now while
Yeah.
debugging. It's like 10, 11 elements in an array.
Can't run it.
Why?
Yeah, I can't run mine because this is GitHub.
Oh, wow.
I'm showing my code in GitHub. This computer doesn't actually have Rust down.
I'm checking mine. Mine has quite a few different basins. It's not printing out all of them, so I can't see. Let me.
You want to share your screen?
Sure.
No, I didn't. Maybe I'll put Rust on here.
So let me just try to console out all of my basins to see the size. Okay, so if I scroll up, it looks like my basins range anywhere from 98 numbers in size. So my top 3 are 98, 94, and 93 being their size. And they go all the way down to basins of size 2. And there's quite a few of those. We have really small basins and pretty much any size basin in between. I got basins almost for every value,
Yeah.
maxing out close to 100. Okay, interesting. It looks like I have close to 200 different basins too. Yeah, just interesting thing I was curious about. I had 251 different basins, it looks like. 250? Okay, there's that. Just to satisfy my curiosity.
Cool. All right. So I think that kind of wraps up day 9. Any other questions?
Are we going to be recording on Friday? Are you guys going to be here on Friday?
Oh, well, that's something we'll have to discuss it tomorrow. The day after tomorrow's Christmas Eve, right?
Yeah, Friday is Christmas Eve.
It's a day off.
I don't know.
I don't know either. You have to talk to Kyle. Anyway, maybe we'll see you guys on the 24th on this Friday. Otherwise, we'll push it to next Monday.
All right.
Right.
I think we're going to be covering 5 questions on Monday. But
Well, we only have a few left anyways.
well, that's
23,
true.
24,
That's true. We
25.
only have 3 questions left.
Yeah, if we wait till
So-
Monday, we only got 3 anyways.
Yeah,
So
that's
it's a
true.
normal day.
All right. Other than that,
And I guess we'll
see
be
you guys-
answers for day 10.
and answers for day 10. We'll see you guys in the next session.
All right.
Take care, everyone. Good luck.
Bye.